My guest today is Anshuman Kumar, the head of hardware at Matic Robots, where he pioneered the mechanical design for Matic, the world's first truly autonomous, private, and perceptive floor cleaning robot. Previously, he was a key engineer at Tesla Motors, resolving critical reliability and scaling challenges for the Model S and Model 3 traction inverters. With a master's in product design from Carnegie Mellon University and a bachelor's in mechanical engineering from IIT Delhi, Anshuman also founded and led the Carnegie Mellon Hyperloop team to be awarded in the SpaceX Hyperloop competition. Welcome to the podcast, Anshuman. It's great to have you here today.
Thank you. Thank you so much. And great to be here. Excited to talk about robots.
Thank you. I'm excited to talk about robots too and learn about robots. So let's just take it from the top. What is a robot?
Yeah, I think that's a great question. The way I like to think about it, it's a spectrum, right? So it's going to be some kind of mechanical device, right? But the spectrum is the level of automation and planning that the mechanical device is doing. So on the far left, you might have something like a screwdriver, right? So everything is controlled by a human. It's more like a tool. In the middle of the spectrum, you might have something like a coffee maker where you push a button, it does a few actions, but that's all it can do. It can't really perceive the world around itself. It can't really make a new plan or new goal or anything like that. Whereas on the far right, you might have something like a self-driving car as of today, where you throw it in a complex environment and it can make sense of the world around it and then move towards a goal, which would be move my passenger from point A to point B. So yeah, I think a robot is sort of this machine that can operate in a complex environment, perceive the world, formulate a plan, and then execute that plan towards a goal. And then the goal keeps changing every time. So it's more like a variable task.
Amazing. So we're seeing more and more robots coming into our daily lives, and we're hearing about more and more robots being built. Why is that happening now?
Yeah, no, I think that's very interesting how that is playing out. I think a big part of it is the key foundational technologies that are needed to give a robot the sort of essential abilities that it needs have started to come together. So a big part would be the GPUs, right? So companies like NVIDIA have really improved the amount of compute that is available for running complex algorithms, right? So all of these, as a human, you run all of these algorithms in your brain. So you have the hardware to run the sort of software, so to speak, right? But robots classically have not had the ability to run very complex algorithms. The second part is the algorithms are also getting better. We've had the hardware for a minute, but then all of the recent work in computer vision, machine learning, and then ChatGPT had its big moment where AI became a household name all of a sudden a few years ago. And so of course that brings along with it a lot of interest from your venture capitalists, your big corporations. Every company is trying to do something in AI. Yeah. So those two things combined, when you have that, you can now start to go towards a fully useful robot. Because a robot is not just one piece of tech. And that's the thing that's really fun about it. You have to have really good hardware from a mechanical perspective. You have to have really good hardware from an electronic, sort of a computer device perspective. And then you have to have the algorithms to actually run the robot. And it's kind of this culmination of all these technologies maturing. And then also the right attention on top of it. That's sort of driving growth, I would say, these days.
Yeah. And how do mechanics, electronics, and algorithms come together to help robots see the world around them? And what does that actually mean? Because they're not conscious, but they're seeing, they're looking, they're getting data from their surroundings. So how can we imagine that? Yeah. Oh, yeah. For now. Okay, great.
Yeah, for now.
Tell me more.
Yeah. I think a big part is so it's the way I like to think about it is perceive, plan, and act. So the perception part is all sensors, right? So I think a big sensor would be your cameras. So human environments, so robots are going to work in human environments and humans mostly use their eyes to navigate any kind of new scenario. So cameras are big. Cameras are your robot's eyes. But then you can have like things like LiDAR, which is essentially a laser that tells you the depth of like, your scene around you. You could have your ultrasonic sensors that use sound waves to do a similar kind of job. And you can have like, your time of flight sensor, pressure sensors, buttons, switches, like all sorts of different sensors, right?
Right.
Actually, all that is a way to learn information about the world in which the robot is operating. And then all of this information gets fed to what would be your computer or your processor that is on board. And you take all that information, and I mean, humans do this as well, but what the robot's then trying to do is apply some layer of abstraction on the real world and build a mental model of it. It's like, for example, like a human understands what a table is just by looking at it, but doesn't necessarily have to know the ins and outs of every single thing that went into putting that table together, right? So that's an abstraction, right? Like you understand the concept of a table, you don't know everything about the table. So similarly, if a robot can understand the depth, i.e. the distance between objects from the robot, it can then understand like, okay, these are places I can drive in, and these are places I cannot drive in because I might run into a wall. Right? So that abstraction is very important. And that's where like, a lot of the work is happening these days, which is like, how do we get closer and closer to reality rather than having some like loose abstraction of the world? And then from there, I think whatever your goal is, whatever action your robot cares to do, you have to apply some logic to then take actions in the world. And that's where your actuators come into picture. So that would be your motors, your hydraulic cylinders, your maybe solenoids, maybe even in the case of drones, these might be
What's a solenoid?
A solenoid is an electromagnet, essentially. So if you apply a current to it, it will like, create a physical motion.
Okay, so I just went to Disneyland with my kids the first spring break, and they have these new roller coasters that aren't on tracks. It seemed like the floor had magnets, and like literally in a Mickey Mouse ride, we were like doing the cha-cha in our ride train thing. I think it was magnets. Is that potentially something similar to what you're talking about?
Yeah, it would use a lot of the similar principles, like electromagnetic principles. I actually worked on something like that. That's more similar to the Hyperloop idea that I've worked on.
Oh, okay.
So what you're doing there is you're using, sometimes this is one instance of how the technology works, is you use magnets to repel each other. And what you can do is you can create an electromagnetic suspension. That's a fancy way of saying allowing, the whatever the roller coaster was to move on another surface without having a lot of friction, right? It's kind of like
it's very smooth.
Yeah, exactly. Because magnets, if they repel each other and they move past each other, they don't have necessarily a lot of friction. So that's what that would be. But then you can also use that to, in a robot's context, to manipulate objects, to apply forces and things like that. Yeah. And I
so
think
lots of ways to move, motors, solenoids, navigating in the environment based on the plan. And then going back to perception and sensors, this is maybe I'm thinking about this from a philosophical perspective, but we're these humans in these bodies, and I can like see things, smell things, touch things, hear things, taste, whatever. Those are my senses. But the world is made up of light and waves and particles and things that have other properties that could be that I can't necessarily sense. And so I guess that's like maybe ultrasonic or but like you could engineer robots to perceive things that would be very useful and practical that are beyond the bounds of our human sensory perception ability, right?
Absolutely. Okay. Yeah. No, I think that those are some of the very interesting niche applications of robots. Generally robotics is especially when it comes to consumer electronics, it's an efficiency play, right? So if I'm going to create a robot that does your dishes for you, it doesn't necessarily do your dishes any better. It just does them so you don't have to do them. So that's an efficiency thing, right?
Yeah.
But the kind of thing you're talking about is like, okay, now it can start to do things that you can't even do. Or like really, really struggle to do properly. So a good example would be in one of the companies, I'm sort of like somewhat familiar with the management there, is Decode Robotics, right? And so they do very interesting work in the energy sector where they will inspect boilers. And so imagine like multi-story big boilers, and they have these like thick metallic sort of like structural, I would say like, members. And those need to be inspected using X-ray or something for like minute cracks. And so as a human, you would have to climb up there with some like, sophisticated piece of equipment to do that. Versus a robot can just have the X-ray embedded, so to speak, and then just climb up this wall and do the job much better, much faster. So yes, there is an efficiency play, but you can also make things possible that a human would really struggle to do.
Right. And then probably also things in the medical space or surgical robotics and things at like a micro scale that humans can't do. All of that is really exciting.
Yeah. Nano robotics, for example, like people try or have been trying for a while to like implement or robots inside the human body, right? Like I think to like G.I. Joe and how there's like certain villains that will release their nanobots on you. They just like take control of your mind and things like that. But that's more science fiction. But in reality, I think like
a little swarm of like mini robots in your blood, like acting like a second immune system or something, or I don't know, they can repair.
Or in a more modest application, like clean up your clogged arteries or something like that. Like
yeah. That would be cool too. Oh my God, wow. And then this is another general question about robots, but the world is super unpredictable. So how do you try to make them resilient to the chaos of normal life? Like we still don't have fully self-driving cars.
Yeah, we don't. I mean, the real answer is you just like try for a long time and you keep working on it. So, I think everything matters in order to solve that problem, and it's yet an unsolved problem, right? I think cameras and computer vision is one of the big vectors in this sort of like solution space, because cameras give us a lot of information as compared to your ultrasonic, your LiDAR, anything like that. Cameras can perceive color. When used properly, they can perceive, and through like multiple cameras, you can perceive depth. You can also use infrared cameras to perceive temperature. And you can also now start to apply like, computer vision on these video feeds to then identify objects in 3D space. Like you can label like, oh, this is a chair, this is a toy, and so on and so forth.
So it can help create that conceptual level of like quote unquote understanding or categorization or something system.
Yeah, for sure. And then, I think the richer your information is, the more effective you can be at your planning in the acting layer. So yeah, I think our sensors are getting better. One of the things that's also in the favor of cameras is everybody as humans loves to take pictures, apparently. That's why Instagram is so big, right?
Yeah.
And so cameras ended up in our smartphones, and then smartphones ended up in everybody's pocket. So there's this huge economies of scale behind cameras that makes cameras really cheap. And it's also like really efficient to use cameras from just a business perspective.
Yes.
And then, essentially what you're trying to do is build enough intelligence into your robot that it can handle all of this information and use that information effectively. And that's where the hard work is. Like, how do you really build a robot that can make sense of the world and act appropriately?
Yeah. And then I talk to a lot of brilliant people from all around the world all the time. And so it sounds from my lawyer brain understanding that you would need a lot of AI capabilities or machine learning to be able to process this visual information that's coming. And then that leads to like edge computing and, how efficient can you be on device to make things faster Like those are
Yeah.
probably some of the technological opportunities that come up, right?
100%, 100%. And you're bringing up a really good point. And this problem is the biggest, or sort of manifests in a strong way in consumer electronics, right?
Okay.
So think about it, like if you're going to use cameras, you're going to put a camera inside people's homes. That's not a great idea to most people, right? Like, what are you doing with my data? Where's that data going? The privacy element gets involved. And, you know, this is where, for example, my company, Matic, there's a lot of very smart people working on this and essentially trying to do all of the data processing on the device itself. So nothing actually needs to be stored offsite. And that's the hard part. So
yeah, and tell us about what Matic does. For context, tell us about
Sure. Yeah, so for context, we are very focused on building robots for people's homes. Okay. The natural starting point is a floor cleaning robot. The way we see it, it's an unsolved problem. And the reason I say that is you can talk to people who use these robots, and without fail, I would say like 90% would be like, it's a terrible product. It gets stuck all the time. It eats up my cords. It like, you know, chews up my carpets. It bumps into my dog. It spreads the dog poop around. You know, it doesn't know where to actually clean. So there's like this long list of like issues with cleaning robots, right? You've probably seen plenty of memes online where like people do all sorts of like funny things with their Roombas. And yeah, so it's like, it's an unsolved problem the way we see it. And a big part of the problem is on the perception and planning side.
Okay.
So Matic is actually coming in and saying, hey, we're going to look at this with a fresh set of eyes. A big deal is, can we use cameras? Because then we have a lot more information than just, you know, a bump sensor, for example. That's what Roomba initially came out with. And then once you have cameras, very quickly you get into like machine learning and then using that information properly to then build a physical model of the world. So the robot that we've designed is actually like, it's back there in the corner if you can see it. So the robot like goes around people's homes and builds a 3D map of the world. And through that, the user can communicate with the robot. And the robot is essentially like a floor cleaning robot that can go around sweeping and mopping your home.
Okay.
But like I would say one of the key technology that we've built is all of this data gets handled on the robot. Like you were talking about edge computing.
Yeah.
So it's completely private. None of the images ever leave your home and everything gets processed on the robot. And that's where you have to really shine and optimize all your algorithms, optimize your like compute, build a really efficient cooling system to be able to enable that. And we're already bringing that to consumers. We've started shipping. So, you know, it's out there.
That's so cool. So basically, you've been able to figure out a way so that the robot can take photographs of your entire house and it's completely private.
Exactly. Yeah. And we're seeing that a lot of customers are choosing to work with us precisely because of that.
I think privacy is becoming more and more important to people as we realize when we don't have it and what that means. For the longest time, I was so confused, 10, 15, 20 years ago about like, why are people so obsessed about privacy?
Right.
But now it's like, oh yeah, you need that. You don't need that. Wow.
I've seen this horrible video where like some hacker got into a disk vacuum, and then the robot is not only like streaming whatever images from the person's home to this hacker's sort of terminal or whatever. It's also like running around yelling sort of like abuses in the person's home, and like that's a nightmare.
Oh, that's horrible.
So cybersecurity and privacy is like I think a very, very important thing when you start putting these robots in people's homes.
There's just a news article about, and this podcast will air in a few weeks, so there'll be a gap, but somebody hacked into the crosswalk buttons here in also programs with billionaire voices. So yeah, you wouldn't want that in your home, for example.
No.
Yeah. No protest art unsolicited in your household. Wow. So as we progress, like I love watching the Jetsons. I've watched that with my kids, and I was like, wait, we still need all that stuff.
Yeah.
Like, where's my Rosie the robot? Where's my instant meal button? Where's my
Yeah.
no? Well, we have the like FaceTime, but there's a lot that remains a promise still. So what do you
Mhm.
think is like the cutting edge for robotics right now? When are we going to get all that other amazing consumer electronics stuff? What are you tracking?
Yeah, no, I think this is the same question like we've been asking ourselves at Matic, and um, I think sci-fi has always sort of like promised us like all these like amazing devices. Like JetSense is great. I also love the movie Wall-E.
Oh yeah,
You
I mean
know,
that's an amazing movie for so many reasons.
yeah, like robots doing all sorts of different things and like
Yeah.
very, very sort of like approachable kind of like robots, right?
Yeah. They're so cute.
They're
And
so
you
cute.
a cute robot too, which I appreciate. It's like
And they're very natural. It's almost like a person that you can like communicate and talk to, right? Like it's not like you're sitting on a terminal and writing commands to try and control the robot.
and it's not this like humanoid scary thing. That's like
That too. Yeah. So I think a lot of the challenge is because of all the sci-fi, which, I'm a big sci-fi fan, the customer expectations are always like here, which is like they kind of expect like a Wall-E type robot to sort of like, come through. But what happens is the technical sort of like mountain you have to climb to make that happen is still like not quite conquered yet. And a big problem is just this idea of like perception and planning, and it's like things that we find very easy as human beings, which is like, for example, getting up and walking up to a doorknob and turning the doorknob and opening the door is so easy and intuitive to us, right? Because we never went to school for that stuff. But for a robot, that's incredibly hard. And then you go on the other side, like, things that we think are very difficult, which is summarizing a 500-page book in like 30 seconds. Right. That would be like a full weekend of a human being, right? Maybe more. That's very easy for something like an LLM to do.
Right.
And so it's kind of this inversion, like you have all the expectations because as a human, you find it easy, but as a robot, it's very difficult to do that because you're competing with hundreds of thousands of years of evolution to be able to do that. But I think the shift is starting to happen. We're
like a marketplace of open source, like robot doorknob, robot door open. I don't know what that would be like, but it's just like shared open source commands.
No, that would be a good idea. I think generally what we see is like there's a lot of like decisions that we've made to simplify human lives that don't necessarily work well with robots. So the fact that there's clutter everywhere and, rooms are difficult to get from one room to another. There's no labels on things, which is obvious. Like that's not how anybody would want to build their home. But for a robot, those things would be very useful. And so we're not going to have people modify their homes so that robots have an easier time. We just have to build better robots so they can fit into these environments and do what they need to do.
And like compute, right, is getting so much cheaper and all the different trends you've mentioned. And I'm curious because you've been at Matic for 6 years now, and has the LLM revolution made it easier? Because the technology you're creating probably doesn't rely on large language models too much, but maybe there's some like downstream effects of that technological improvement.
Yeah, I mean, I think that's something we could unpack for hours, but like I think at a very high level, yes and no.
Okay.
LLMs are just useful tools for anybody writing code, and we write a ton of code in this company, so yes, it's useful. Yeah. So in an indirect way, it helps a lot.
Yeah.
But when you start to try and apply an LLM to a robot, it's a very interesting thing where, LLMs are trained on data, mostly text that's available on the internet. And the text that's available on the internet describes things that people talk about. Now, people don't...
It's not reality.
Yeah, people don't usually talk about the intricacies of using your fingers to open a doorknob, to make this example, right? Like nobody's sitting there writing a 3-page essay about like how they move their fingers.
And I extended my thumb. That
exactly.
Grasp took hold. Yeah, no.
So what happens is like you can use an LLM to do very, very high level planning in the context of a robot. But when it comes down to the brass tacks of interacting with the world, an LLM cannot actually control your motor torque. It cannot control your wheel RPM. It cannot control your solenoid or your actuator, so to speak, right? And that's where there's a huge bottleneck. So you need to kind of still work your way up, both from the bottom and top down, to like make software that is able to do everything that a robot needs to do. So in that way, LLM doesn't really help that much.
Okay. Wow. Wow. And then what are some of the macro trends that you're seeing, like bringing back manufacturing and different supply chains? There's so much that might affect the physicality of the hardware, but yeah, like how's America doing with robotics? How are we advancing it? What's here?
Yeah, no, I think America does and will continue to play a huge role in development of tech and robotics by extension. I think part of the reason is just there's sheer number of entrepreneurs in this country, maybe something about the spirit of the country that sort of enables that kind of, adventure or pursuit, if you will. But then also, like, I think we have a big consumer market. There's big industry in the US. There's a lot of people who can afford expensive products. And, human labor is sufficiently expensive, but it does make sense to invest into building robotic solutions. A good example I have is like, in India, where I'm from, we have this flatbread. It's called rotis. So there's this very popular company that built an appliance that can create rotis for you. So it just takes flour and it, shoots out rotis the other end. It's great. And you think like, oh, it's rotis. Rotis is for India, so people would be mostly buying that in India. But that's not the case at all, because the thing is so expensive. Most of the customers are Indians who live in the US, right? So the US market just enables that amount of innovation because it gives you a bigger budget to work with. Not only in the consumer electronic space, but also in like, other applications, I would say. And then what happens is we have out here in the US the impetus to create these technologies. And then once we do the hard work of creating those technologies, finding what actually works, what doesn't work, then maybe the rest of the world can find like use cases where they can like actually take bits and pieces and create sort of like, more customized local solutions.
Plus, in that specific example, there's so much ability to scale in the US market, because let's even say that like the Indian diaspora roti is your starting point, but then like, okay, can you also make pita and tortillas and pizza crusts? Because
of course,
we'll buy that here too.
Yeah. There's a lot of diversity.
Yeah. Wow, interesting. And how does Matic want to position itself as you grow and then potentially expand to other types of consumer electronic robots?
Yeah, for sure. I mean, I think the way we see it is like floor cleaning really isn't a solved problem. I think in the US, the way we see it, almost 100% homes beyond a certain level will have some kind of manual vacuum cleaner, right? But only like 12 to like 14% homes have a robotic cleaner as of today.
Okay.
And it's mostly because the tech isn't great. Like people don't trust the tech to actually do what's been promised. So floor cleaning is a big sort of initial beachhead for us. Like we want to build out really good tech, really good product, win the consumer heart, and then really, really like, establish this as a product category that drives growth for us. But then we already have started working a lot in the next category of product, which would be like storage related tasks. So imagine like, picking up your shoes and putting them in a closet, or like, starting to think about like if, your kids' Lego toys all over the place and putting them in little bins. And I know that's a huge headache for a lot of people. So if we start to build that out, I'm very excited about where that takes us.
That would be really cool. Yeah, because if you can do that for me, then you can fold and put away my laundry. You can put the dirty dishwasher. Do you need like a humanoid shaped thing to do those tests? And does everyone need a different robot?
I am a huge proponent, just as my own design philosophy, to minimize complexity.
Okay.
And this is critical for building an effective and efficient hardware solution, right? So humanoid is more intended as a one size fits all solution. In by definition, a one size fits all solution is going to have a lot of bells and whistles you don't need for every use case. So to cut to the chase, like I think I am much more of a fan of like purpose-built, purpose-designed solutions that solve the one thing or the two things it's supposed to solve, rather than trying to boil the ocean. So I would really hope that we don't need the humanoid. Like a very basic example would be like, you're mostly rolling around on flat floors or moving around on flat floors if you're a household robot. Why do you need legs? There's no logic to having, you're not climbing staircases necessarily. In some homes you might, but like even that can be simplified a lot.
In the Jetsons, Rosie had wheels. So.
Yeah. And then legs are loud. Like imagine like a large humanoid with steel legs walking around on your floor. Like that's not a pleasant thing. No. And what if the thing falls on your baby? Like you don't want that. So there's a lot of like, things to think through before going to a humanoid form factor.
Wow. And then I guess you could argue that, well, then you would just have one robot for everything and everything would be cluttered with robots. But maybe the counter argument is like, well, if the robot is simple and efficient, you can kind of like decrease it to the minimum that it needs to be and maybe fade it into.
Yeah. I mean, even for like a robot butler, I would say humanoid form factor is a stretch. Like you could give it wheels, you could give it, maybe one or two arms, but I would try to build the smallest robot possible just because that's what I think is reasonable. And that's what the customer wants. Like people don't want huge robots running around, especially me. Like I live in a studio apartment. Like I don't want the huge humanoid also living in there with me.
Yeah. Anshuman, could you speak a little bit about just like you originally are from India, you came to the US for Carnegie Mellon, you've built this amazing career at Tesla and now Matic. Any words of advice to people who are, maybe F1s and wish that they could work in exciting new technology areas and how they could navigate that career path?
Sure. I think I am very well aware that the sort of like, I guess, landscape these days is very different from when I showed up. And it seems like it tends to get more and more difficult as the decades go by. But generally, I think no matter if you come to the US or you go to any other country, I think pursuing genuine curiosity goes a long way. For me, that was like this idea that, okay, I understand something about mechanical engineering, which tells me how to build a product. But I had this idea, it's like, I don't know why I would build a product, like which products are worth building. And that's what brought me to the US and drove me to get my master's in product design. And then from there, it was like, I was just genuinely curious about how you organize a big engineering team, especially after my experience working on the Hyperloop problem in college, right?
Yeah.
And so I wanted to work at a firm which was developing a very complex product and working with a big engineering team. And that's what I found at Tesla. And so that was a natural kind of motivation for me to go learn that.
Yeah.
And then 2 years later, it was like, okay, I want to understand how a company is built from scratch. And so that's what took me to a startup, right? And so I think if you're naturally just allowing yourself to be curious about things and letting that drive you, you will have this sense of like purpose and motivation in your work that hopefully carries you through all the ups and downs. And you can stick with it.
Yes. I think that's super important. I was a stay-at-home mom for 4 years before deciding to start my immigration law firm. And I had previously practiced immigration law with my dad. But one of the things that drove me was this design thinking class that I took at Stanford called Building a Career of Meaning and Impact. And it was about applying design thinking principles to our life's work. And when we have that sense of curiosity, the motivation is so much higher if we're invested and our heart is in the work. It makes such a difference for getting through all the inevitable hard times that are bound to happen to anybody just naturally in life and in one's.
For sure.
Yeah. And I'm also curious, since you've now had this learning opportunity to see this very successful robotics company grow over 6+ years, what are the natural challenges in a startup, especially like a hardware robotics startup, and any insights that could help people who are, potentially going to be starting their own such companies?
Sure. I think startups are hard. Hardware is harder. And I think robotics is 10x,
Okay.
like another order of magnitude. So in it, like, I think if you're trying to start robotics, but then also starting in the far end of complexity, like, you know, I come across a decent amount of sort of new startup founders that have never done a startup before, but they pick humanoids as their first thing. And I'm like, the market case is kind of dubious. The technology is probably the hardest thing humanity has ever built. And, you know, funding is always going to be tight because there's like so many people doing it. I just don't know if that's the best place to start. My advice would be study the market and find a slog, boring, unsexy thing that requires to be, you know, improved or radicalized. And you find like some radically better solution rather, and just go work on that and find something where you won't have a lot of competition. Where you can just like dedicate a long period of time, say 5-10 years, plan in like decades rather than like months if you're going to do a startup, and then just go work on that rather than catching the next wave of hype and trying to build what like 50 other startups are building, and will probably be a sort of like, you know, race to the bottom kind of situation.
That's really insightful. It's very helpful. It's so easy to get swept up in the current funding trends, but creating something of value that you want to stick with for decades, like that's actually how great companies are formed.
Yeah. I think it starts like people say, like, I mean, people say both things. Like some people are like fixated on ideas, right? It's all about the idea. It's like, no, like idea is 1%, execution is 99%. But then the idea does matter. That's your starting point. And if you have a terrible idea, then you could execute really, really well. You're still going to end up in a terrible place. So I think it's a balance, and you have to think through what you're trying to do.
Yeah, absolutely. Okay. And then last question on Anshuman. We've mentioned, you know, everybody goes through these ups and downs. Are there any words of advice or inspiration that have helped you get through any of those inevitable hard times?
I think I would be sort of like, I don't think there's like one liner that I say in my head or anything like that. A lot of it comes down to like, for me, and I'm also a very hyper rational person, I would say. So I think when things get tough, like I do tend to like sit down and journal and then figure out like, why am I in this and why am I doing things? And for me, that works a lot, right? Like I've had like tough times with regards to my career, with regards to like, you know, sort of like, you know, adjusting in the US also, but like understanding what is my overall motivation to try and come to the US and build a life here. So you have your why in place. And that can be like 5 different things, or it could be one thing, but you have to figure out why, what is it for you? And once you have that front and center, the how you can figure out. So I think journaling is a good tool for me to get to that.
Thank you. Yeah, it's all about that North Star. Thank you.
Sure.
Amazing. Well, Anshuman, it was delightful chatting with you. I learned so much. I'm really excited to see everything Matic does and everything you will continue to create. Thank you so much for joining me today on the podcast.
Thank you so much. Thank you for having me. Lovely talking to you as well.
Thank you. And to all of our listeners, we'll put Matic and Anshuman's links in the show notes so you can learn more about what they're building. And please share this episode with a friend, anybody who's interested in learning about robotics or hearing inspiring stories of immigrants who are making it in Silicon Valley. Definitely subscribe to the podcast. And also in the show notes, you can check out our Alcorn Immigration Law newsletter, where we include the latest updates on everything that is happening in immigration. So thank you, Anshuman, so much. Have a wonderful rest of your day.
Thank you. You too.